Okay, so to answer those questions for those of you who figured it out, or those of you who were smart enough to look up in the top left-hand corner, you would have realised that in this case the slope of each one was identical, which also means that the gradient is identical. Okay, so these ones all had the same gradient. If we go to the second one, yet again, some of you might have been smart enough to figure it out. Some of you might have just looked up in the top hand corner, but you should have realised that all of them go through this exact point, which is actually our y-intercept. Okay, so in this case, our y-intercept is at 1. And that brings us to something known as gradient intercept form. Now, gradient intercept form is a way of writing equations using x and y, where all you need to know is the gradient and the intercept. So the way we write it is as y equals mx plus c. All right, so the thing to note here, I'll write M in a different colour, M, and our C, I'm writing them in a different colour because they actually become numbers, all right? So our M, that's equivalent to the gradient of the line. Oh, go back to a thinner writing, gradient, lovely neat writing. And C represents our y-intercept. So we could see in those previous graphs that if I kept this m, the number that goes in front of the x, if I kept it the same, the gradient stays the same. But for the second graph, where I was changing this, suddenly the gradients all changed. The opposite happened with C. For the first graph where I changed it, the y-intercept of all those different graphs was different. On the other hand, for the second graph where I kept this as +1, the y-intercept stayed the same. All right, so this is our gradient intercept form.